Hello guys, welcome back. Thanks for joining. My name is Gaston Cacheffo. I'm a tech manager at Globant. Globant is a digitally native company. We help organizations to reinvent themselves and unleash their potential. We're plus 26,000 employees and we are present in more than 20 countries. We work for companies like Google, Electronic Arts, Santander, among others. So thanks for having me today. And let's jump into our topic, which is microservices from a DevOps point of view. Before to begin, I want to thanks to Luis Pulido. He is a solution architect at Globant and helped me a lot to elaborate these topics. Next, setting your expectations about this presentation, we will introduce the concepts of microservices and DevOps in order to discuss about its challenges and how to get the most from them, avoiding falling into high complex operability scenarios. Let's move on. Let's begin with the topics that we are going to address. What are microservices and why use them? What is DevOps and its relation? What are the challenges? Where to start or CI/CD planification, what to consider, and where to go. Microservices. Let's introduce the concept. According to Wikipedia, a microservice architecture is an architectural pattern that arranges an application as a collection of loosely coupled, fine-grained services communicating through lightweight protocols. Anyway, you can find many others. Consider as an evolvement from monolithics, a method to break down software into smaller pieces, etc. What is important is not here, in its benefits. As anything, benefits carries complex challenges also. We will see later on. Then why to use them? Well, let's enumerate a series of advantages. Fault isolation. As simple as the idea that in a distributed service architecture, the affectation of one of them does not imply the total loss of the service. Your application will still work, probably. Data isolation, probably the root idea for microservices architecture design. I'm not a theorist on microservices anyway. Each of them will own an information or data domain and its related logic. You get benefits such as smaller schemas changes, isolated risks, and perhaps the base for loosely coupled concepts, or expectations at least. Then scalability. The ability to independently escalate different parts of your infrastructure, either using shared escalation rules or customized one. This carry with a significant increase in resource consumption efficiency. Independent deployment. Well, microservices is about having independent life cycles. So microservices modifications can independently be promoted to higher environments without expecting a service disruption. We will rely on a battery of policies and tests to prevent merging and promoting faulty changes. What is DevOps? You may have heard about this duality. There exists, it is a fact. On one side, a tech industry position, and in the other, a more accurate approach considering DevOps as a culture movement. By definition, the cultural side is a set of practices that combine software development and IT operations. It aims to shorten the system development lifecycle and provides continuous delivery with high software quality. Again, there are many other definitions. Then we have a tech industry software who implies have these roles personified and a team member who will care about integration and deployment automations, among others. From operational models, we can find this position into a full DevOps team or a team member into an application development team. You may use to be part of one of these operational models. A center of excellence may also be there in order to centralize and standardize this discipline. Well, microservices and DevOps. Its relation. Either as part of an application team in a DevOps position or an app team which embrace DevOps as culture, will have to lead with the software development lifecycle, right? Of many microservices, and many could be a really big number. It will become a multiplier factor for the architecture components your team will have to deal with. The more the microservices the more components in your architecture. Let's jump now into challenges with microservices, and let's begin with promoting code. And this is a very good question you have to make yourself. Have you ever thought about how much time a developer dedicates to exclusively code new features? I understand this is the DevOps side of the force, but from a cultural perspective, everyone has to embrace DevOps. Mostly in multi-repository, app teams will lead with merging code between many branches, feature, hotfix, dev, release, main, etc. And depending on how deployments are triggered, this frequently could consume an important amount of revision time. High complex deployment scenarios who haven't been there. Well, this is a situation where you can easily fall with microservices, packing smaller changes by grouping them in a giant release, and those groups have to consistently travel through different environments. Consider the time and the effort this consumes. Retrocompatibility. This is a challenge, but one you should be having. Retrocompatibility is a must. A way to code your change considering they're going to be promoted independently and current service consumers will stay working. Next, quality assurance. The main challenge with this is constant validation. This is not just about a single environment. You will need your QA team and tools available on demand. The more manual the validation and group the changes, the greater the QA bottleneck. Database updates. Well, microservices iterations may imply more schemas and database updates than desired. From another point of view, this shouldn't be a problem to bring to the team. In any case, it used to convert into one, right? Due to manual script executions and code deployment extra coordination, this may involve. Finally, debugging. With monolithics, all logs are in the same place. With distributed architectures, logs are not. And obtaining the root of the problem may become a slow process. The more components, the more difficult to trace. Finally, here we are. Planification guide. Let's do what psychologist doesn't. So just advice, for instance. We're going to describe these topics until the end of this presentation. This is just a quick overview. Branch strategy, the base for automation, something that you have to consent with your team. Lightweight microservices, remove from microservices whatever role you can centralize. CI/CD strategy, tips to automate your software delivery life cycle. Configuration, establish policies, secure and get governance of. Quality assurance, align your QA with microservices objectives. E2E tracing, love this one. Get a tool to correlate everything related with monitoring your app. And finally, feature flags. Possible the Saint Grail with microservicing, at least from my point of view. And Luis also. Well, let's begin with brand strategy. There is a great video you must watch on this topic from the great Victor Farsik. Probably you know him. He have a channel on YouTube called DevOps Toolkit. A great talk about branching strategy. Well, our first advice or topic here, trunk-based development. The main message here is not getting into complex to complex branches strategies, right? The more branches, the more automation complexity, or worst, an extremely amount of dedication for getting your changes ongoing. Trunk-based development, or this kind of trunks, similar ones like GitHub Flow, for instance, or the ones you want to customize based on any of those, are fairly straightforward. You'll be able to quickly automate into your pipelines. Spend the necessary time with your team to decide, document the entire process, and invoke, this is important, frequent talks to reinforce it. Use Git tags for versioning. A simple advice, probably going too far here, is using Git tags for versioning. This doesn't require commits into your branches, and you'll be able to carry them everywhere, from pipeline triggers to app configuration environments, logs, traces, and so on. Build validation. This is a key feature you have to look into. It's a key tool for code merge policies. When PRs are created, a set of actions can be triggered. Usually several pipelines will validate your code looking for vulnerabilities, regressions, build integrity, performance behavior, etc. This is the place where you want to deeply check your changes in search of faulty or unsecure code. Uh, Finally, version your APIs. Another architected design convert into a tool for have close to us. It's a tool that you need to develop. Whenever our changes doesn't go retro-compatible, and it will happen, and you have to introduce a major change, you may deploy a new version of your API and getting your consumers with enough space for asynchronous migrations. Next topic, lightweight microservices. What it's all about. The first one is remove unnecessary roles from microservices. Keep your microservices as the word suggests, right? Remove whatever role you have the ability to centralize. Authentication and app roles is a great place to start. You can delegate this role to your API manager. Most of them will have the ability to handle the authentication layer. And if your microservices need token information, you can export this to headers or parameters, right? IDP. This one is going to be quite obvious for majority. Do not waste time coding an identity provided for your application. Besides the invert amount of time, you'll probably stay at a halfway with unsecure or vulnerable one. Getting an external IDP, which nowadays isn't costly at all, with pricing, I guess, pricing strategy based on traffic amount and premium features, totally affordable. You will obtain a considerable high security level by continuous security updates, those provider involved, and a lot of useful features you probably require further on for your application. To name a few of them, Google, Facebook, Microsoft, Okta, there are many and big ones. App roles. Okay, another annex in the line of the previous is to similarly deal with applications role. Most of the applications fall by design with this requirement. Then you can take advantage of core IDP features. JWT tokens related to OAuth authorization you are probably using. OAuth, it's an authorization protocol. Can include app roles, sure. For a given user, for instance, you can get information into the token, user information, and consider its roles from different sources like directory groups or specific declare application roles. CI/CD strategy. Let's begin by splitting them. It refers to pipelines, of course. Your integration strategy will have the different roles than your deployment, and deal with them separately will have the advantage to isolate, simplify its configuration. You will rely on your triggers and merging policies to invocate them. Remove artifacts. Well, trust me, during a production incident, you don't want to deal with the phrase that code shouldn't be there or this is not what I've tested. As a counterpart, if you're not promoting, then you're over integrating. And this carry with several uncritical disadvantages. In one side, as introduced, you cannot guarantee that your artifacts will be the same. Worst case, when you're including environment configuration, that happen a lot. And on the other side, the excessive time consuming, either be short or large, will be present by the number of microservices you are dealing with. Next one, use templates. Avoid duplication, as a cross rule for governance of distributed architecture is mandatory. Having said that, coding templates will centralize the most common tasks and expected CI/CD automation behavior. When changes arrives, you can quickly iterate all your automation. Consider additional triggers. This this is related with the idea of automate everything. Automate as much as possible. Code your agreed software delivery lifecycle policies, for instance, into your pipeline as much as you can. Triggers then will increase your automation alternatives to invoke your pipelines. Consider Git tagging and other pipeline succeeds, commits over certain branches, artifact updates, etc. Automate your schemas iterations. Well, here, not having a tool to handle the schemas updates in an automated way into pipelines imply getting expert teams, probably externals, getting involved during deployment, planification, and execution. Another pain to this approach with multiple environments and low frequent deployment is forgetting changes, followed by deep debugging into incidents until you realize. To name a few of them, I'm talking without sharing, sorry. To name a few of them, you have flyway or leaky base. Those are pretty common. Automate your API's definition iteration. As code evolves, so do its endpoints or methods. As you may probably have with microservices and API manager, those iterations need to be considered. Get a tool to extract an API definition during integration, this during the build, and use it to update your API into your API manager instance. For instance, for .NET you have Swashbuckle. For Spring Boot in Java, you have Spring Dog OpenAPI Maven plugin. Configuration. This could be another chapter to discuss, but let's stick to some of the key ones. What was that, right? Variable policies. There you have an example. Do not commit sensitive information, group, or centralize common microservices variables. Take your time and agree with your team the list of rules for variable governability. Well, in this example, we mentioned four types of combinations for either sensitive variables as environment and its environment relation. Environment affect variables or not means its value change when artifacts change from one environment to another. Those sensitives needs to be hide of the variables, the sensitive variables needs to be hide and should be stored into a vault. Non-sensitive environment effect can be stored into a library or group, depending on your orchestration tool. And finally, non-sensitive and environment not related can remain into app property files. Of course, if you have common microservices values and environment not related as condition, you can address that by also grouping into a project shared configuration file. Environment variables for app properties. Kind of obvious for most of us. Let me say it is not obvious for everyone. Use environment variables for applications configuration. It will facilitate the promotion idea, and you will find almost every hosting and orchestration tool is compatible with this approach. Common infrastructure environment variables in Kubernetes. Well, sorry, I have to say about pretending everyone is doing Kubernetes. In any case, I found this quite interesting among other excellent features for Kubernetes. Besides being able to group applications' common configurations into independent lifecycle by using config maps, you can also consider this to handle common infrastructure dependencies configuration. We can mention base URLs, domains, credentials, external service domains, etc. This allows to massively update infrastructure configuration change independently of your microservices software lifecycle. Quality assurance. Understanding limitations, one of my favorites. If you discuss with your team and application stakeholders, you may find not everyone shares the same understanding about QA. If you have this role not automated, then you will find a trend to avoid continuous deployment. It kind of becomes a barrier. Distinguish between business detail features validations over the need for code changes validation. You will probably find space for improvement. Code your tests. The more frequent and unattended site for deployments, the more testing automated needed. Stick with this. It's part of the mentioned problem. So for your microservices, you don't want a bottleneck within your quality assurance. Then code the tests and include them into build validation. We've covered this topic. And also, if you can, on environment validation also. Quality assurance versus user acceptance environment. Similar to the previous, to the initial one. Kind of reminder for a not as obvious situation that you may consider. I'm going to literally read it. Understand the purpose of each environment. Don't mix the roles during QA and UAT. QA as near to developers and test automated as possible, and UAT to dedicate business user validation if needed. E2E tracing. Use an application's performance monitoring tool. If you're not familiarized with this type of tools, then you should. I totally find this more useful than plain logs. With a distributed architecture, you will get the features you need to understand how your application is behaving. With E2E, it refers to the correlation of different types of traces, allowing a full visualization near real time of your microservices interactions to resolve their functionality. You may include your logs, business events, exceptions, etc. You will get code insights to understand where something breaks or what part of the response chain is consuming the higher amount of time. Real-time business monitoring from APM. A recall to something mentioned, don't use your database for operative business monitoring. Don't compete with your microservices resources. Insert business traces into software like APM. For executive business dashboards, you may need anyway access to the database, right? But in those cases, you can recur to your provided database's features like replication. In any case, avoid any direct access to the database. Should be prohibited. Finally, limit the amount of traces ingestion. Well, this is related with ingestion and indexing. This is a perform and economic cost you want to efficiently delimit. Add daily caps into your ingestion services, sampling on higher environments, and avoid duplication. Sampling is a great way to deal with production. Your business events doesn't have to fall there, so you have full visibility of your business, and you will have a great sampling for your applications behaving. Even you can create rules like having 100% of the errors, etc. Feature flags have the potential to be kind of saint grail for microservices, but that's my opinion, and you are allowed not to take into consideration. You may have a pretty better ideas than feature flags. It is something that it's been used a lot by the industry. A new paradigm. It will help on this continuous deployment idea. Consider this as a business tool. By having flags to control the availability on your features, that will allows you to separate business requirements from continuous deployment. It becomes important to convert business features into small microservices well-detailed technical user stories. Finally, be able to unattend and independently deploy strong validated change automatically to production. Further considerations. Okay, something that we have a list of enumerated features that we may include or consider within our application. Canary deployments. Consider blue, green, or rollout as also valid alternatives, right? In Canary case, you'll be able to add many stages into your deployment to production, as you may have identified an isolated segment of users. Idea is iteratively increment your code changes or business features in a controlled and progressive way, and not affecting all your consumers or user with a single deploy. Configuration server. As it's all about centralization and governance, this implementation will decrease your application configuration changes among other advantages. You want to go faster with a configuration change. Either those configurations come from applications necessities or infrastructure necessities. A configuration server could be a key tool there. Infrastructure as code, another Saint Grail. A place, another paradigm you should get involved with. Coding your infrastructure will allow you to remove human errors when updating or deploying new architecture components. Also reduce the overall risk. You will have a real disaster recovery plan and a tool for reusability. Finally, Center of Excellence, another favorite here. If you're part of one application team among others in your organizations with similar functions, then you may conform this office in order to standardize research, support and training in a particular area of knowledge. By definition, cross-functional team who provides best practices, research, supports, trainings, or focus area. You may have different kinds of knowledge areas. You can have an expert, an agile expert, in order to promote your agile situation. Also, you may have a .NET specialty with their improvements and their life cycle. You can generate several of them, and you can split them in terms not to occupy the same projects, for instance. But a center of excellence will be a helpful tool for standardize your organization. So that's all for today. I want to again give the thanks to Luis for his collaboration. Here our information contact, hopefully also in description. I also want to thank Conf42 and Glovan for this invitation, and finally to all of you for attending. Hope this will help in some way to make your DevOps life easier. Bye guys.